Hello, welcome everyone. Today we are going to deal with diffraction of light. Okay, so what is diffraction of light? Diffraction of light. So, bending of light rays from sharp edges of an opaque obstacle or aperture and its spreading in the geometrical shadow region is defined as diffraction of light or deviation of light from its rectilinear propagation tendency, and it is defined as diffraction of light. So first case is diffraction from obstacle. Suppose this is obstacle and this is screen, so light is going, strike, return back, gone, return back, gone, return back. But a light which is hitting at the edge or the corner, bend. A light going and hitting at the edge, bent. Okay, and this light ray goes without any disturbance. This light ray is going without any disturbance. So this is the case of diffraction from obstacle. Diffraction from what? Obstacle. Second one is diffraction from aperture. So this is screen and this one is aperture, right? So light went and passed through it. Light went and pass through it. But a ray which is striking at the corner, diffracted. A ray which is striking at its corner, diffracted. So this is the case, diffraction from aperture. So bending of a beam of light around an obstacle is called what? Diffraction. When secondary wavelets emanating from different points of a wavefront interfere at different points of a screen, an intensity distribution pattern is observed called diffraction pattern. One marked difference between an interference pattern and a diffraction pattern is that in interference pattern all the maxima are of same intensity, and in diffraction pattern intensity gradually decreases. Secondly, in interference pattern, waves from two distinct coherent sources interfere, whereas in diffraction pattern, secondary wavelets spreading out from different points of same wavefront interfere. Diffraction phenomenon has been divided into two categories. One is Fresnel diffraction and other one is Fraunhofer diffraction. So in Fresnel diffraction, in which the source and screen are very close to the diffraction obstacle or opening, whereas in Fraunhofer diffraction, both the source and the point of observation are at infinite distance from the diffraction obstacle or opening. Okay, so now I am going to proceed with Fraunhofer diffraction. Fraunhofer's diffraction due to single slit. Okay, so I am trying to draw diagram. This is a single slit and this one is convex lens. This is source. It is started. Here it is not diffraction taking place. Here what is happening? Refraction taking place, and it became like this. But here what is happening? This is a screen and a ray is going in this way, and here we have put a convex lens. So afterward what happens is that refraction through this lens, this approaches this point. This is point P. This ray is also approaching this point, and this ray is also after refraction approaching to at this point. Okay, so diffraction taking place at this corner. One more ray, I am talking about one more ray. uh, this ray gone directly, this ray gone directly, and this ray gone directly and struck at this point. So this is central maxima, this is central maxima, and it will be always bright, always bright. We have named it O, and this is point P. So an interference pattern is observed, and when I have taken this angle theta n, this one is again theta n, this one is again theta n, and this is A. So of course this is also A, and we have drawn perpendicular like this. So of course this is A sine theta n, because this is also what, theta n. Okay, this is convex lens, this is lens L2, and this is lens L1, and we have taken this one as capital D. Okay, and this is your what, screen. Okay, this is point A, and this is point B, and this is point B dash. So when path difference, between secondary wavelets coming from A and B is n lambda, or twice of n lambda upon 2, this is also the same thing, or even multiple of lambda upon 2, then minima occurs. Okay, so what is path difference? A sine theta n, and this is equal to 2n lambda upon 2, where n is what, 1 2 3 etc. Next thing is when path difference between the secondary wavelets coming from A and B is 2n plus 1 lambda upon 2, or odd multiple of lambda upon 2, then what will happen? Maxima occurs. So for maxima, a sine theta n, which is path difference, 2n plus 1 into lambda upon 2, where n is 1, 2, 3, etc. One more term is defined as linear width. Wx of central maxima, and Wx is equal to 2x, which implies that 2x is equal to 2 lambda d upon d. One more term is defined as angular width of central maxima, and this is w theta, and w theta is 2 theta and twice lambda upon. Okay, so we have gone through diffraction. Thank you so much to all of you for showing your great patience.